All right, let's get into it. We're about to explore the surprisingly huge and ever-growing world of mathematics. We're going to see how it broke out of its traditional home in physics to describe, well, pretty much everything from a work of art to maybe even your own consciousness. And that's exactly where we're starting.
So think about this for a second. What on earth could possibly connect the predictable dance of the planets, the messy genius of a masterpiece painting, and that little voice inside your head right now? Well, you might be surprised to find out that the answer is a kind of hidden mathematical structure, a deep set of patterns that links them all in some really unexpected ways. So, here's the game plan. We'll kick things off on math's home turf, its classic relationship with physics. Then we'll see how it conquered chaos by learning to model systems that are all tangled up. After that, we're going to ask if there's actually a formula for creativity. And finally, we'll push into the ultimate frontier, the mathematics of consciousness itself. It's going to be quite a ride.
Okay, first up, the classic, super powerful partnership between math and physics. For centuries, this was pretty much seen as the one and only kingdom where math really, truly ruled.
This idea isn't new at all. Way back in the 17th century, Galileo just laid it out there perfectly. He basically said that to understand the great book of the universe, you had to learn its language. And that language, he said, is mathematics. This one idea really set the stage for centuries of incredible scientific discovery.
But here's where it gets really interesting. Even though they speak this common language, mathematicians and physicists are kind of like two totally different tribes. Mathematicians, they're obsessed with rigorous proof. They build everything up from these fundamental starting points called axioms to create theorems that are absolutely 100% true. Physicists, on the other hand, they just want to understand how stuff works. They build models, they make predictions, and they run experiments to see if they're right. So one tribe is forging these perfect, unbreakable tools, the other is using them to build a working model of reality.
Okay, so what happens when things aren't as neat and tidy as planets orbiting the sun? What about all the messy stuff? Systems where every single event depends on the one that just happened. This is where math's kingdom starts its next great expansion.
And believe it or not, this huge leap forward didn't come from some quiet, sterile lab. Nope. It came from a bitter, full-blown intellectual feud in early 20th century Russia between two mathematical giants, Andrei Markov, a guy known for his temper, and Pavel Nekrasov, who was a deeply religious man loyal to the Tsar.
So here was Nekrasov's big idea. He was looking at social data, things like crime rates, marriage rates, and he saw they were really stable over time. He claimed this was the law of large numbers at work. Now, back then, everyone thought that law only applied to independent events. So Nekrasov argued that this proved people's decisions must be independent acts of free will. He was literally using math to prove a religious and political point, and this made Andrei Markov absolutely furious.
So Markov sets out to prove him wrong, and the way he does it is just brilliant. He uses Russian literature. He takes 20,000 letters from Pushkin's famous poem, Eugene Onegin, and starts analyzing them. He shows pretty clearly that the letters are dependent. A vowel is way more likely to be followed by a consonant, right? Then he builds this simple model, a chain, where the next letter type depends only on the current one. And here's the killer blow. He proved that his chain of dependent events still followed the law of large numbers. This completely demolished Nekrasov's entire argument. Turns out, you don't need free will or independence to get stable patterns.
And the impact of this discovery? It was just world-changing. Markov chains became the key to modeling all sorts of complex, messy systems. They were used in the Manhattan Project to figure out how much uranium was needed for the first atomic bomb. They're the engine behind Google's PageRank, the thing that organizes the entire internet. And yeah, they are the absolute fundamental building block for the large language models that are changing our world as we speak. All of that, from a feud over poetry and free will. So if math can model messy, dependent things like text, where do we go next? Well, how about the messiest human trait of them all, creativity? Can you really put a formula on a masterpiece? Look at this number, 1,093. What is that? That is the number of U.S. patents held by Thomas Edison. Now, we remember him for a few brilliant inventions, right? The light bulb. But the man produced a staggering volume of work. And that little fact hints at our first mathematical principle of creativity.
It turns out if you want to be more creative, math actually suggests a kind of formula.
First, just produce more. Like Edison or Picasso, quantity dramatically increases the odds of a high-quality breakthrough. It's the law of large numbers again. Second, recombine things relentlessly. Most new ideas are really just new combinations of old ideas. Third, you gotta stick with it. Skill doesn't just grow in a straight line, it compounds, like interest in a bank account. And finally, you have to find that edge of chaos, that perfect sweet spot between rigid order and total randomness. That's where the most interesting new patterns pop up.
Okay, we've gone from physics to poetry to creativity. Now for the final frontier. Can mathematics actually model the deepest mystery of them all, consciousness itself?
One of the big ideas out there right now is called integrated information theory, or IIT. And you can think about it like this. A digital camera might have millions of pixels, but they don't talk to each other. The whole picture is really just the sum of its parts. A brain, though? A brain has billions of neurons that are massively interconnected, constantly sharing and integrating information. IIT basically says that consciousness is this measure of integration. It's the extra information the system generates as a whole, something that's way more than what its individual parts contain.
Another really powerful idea is the free energy principle. This theory basically frames the brain as a prediction engine. It's always building a model of the world around it and trying to minimize surprise. So when you reach for a doorknob, your brain is predicting its location, its temperature, its feel. If the handle's suddenly not there, that's a huge moment of surprise your brain has to scramble to correct. And from this point of view, basically every thought and action we have is part of this fundamental mathematical drive to make our predictions match reality.
And look, these mathematical models are so crucial for understanding the whole debate around AI today because they help us draw a really sharp line between intelligence and consciousness. Intelligence, that's just statistical pattern matching. Consciousness is subjective awareness. An AI can beat a grandmaster at chess, but it has no idea it's even playing a game. It can act brilliant, but it's what some people call a zombie. There's nobody home. It doesn't know that it exists.
So, what a journey, huh? We've gone from the elegant, clockwork equations of physics, through the messy, probabilistic chains in our language, to the potential formulas for creativity, and finally, to the code of consciousness itself. All of these worlds that seem so separate, all united by the universal language of patterns.
Which leaves us with one last really profound question to chew on. Is consciousness simply what happens when matter becomes so complex, so deeply integrated, that it stops just being there and starts caring that it's there? Is it possible that the universe, through the language of mathematics and patterns, is finally becoming aware of itself? That's something to think about.